It's all about the Earth and what we can learn about it from the International Space Station. Hi, I'm NASA astronaut Tracy Dyson. Welcome to Station Life.
Houston on 2 for velocity confirmation. Go ahead and leave steps 4, 5, and 4, 6. We're moving on to
Tracy,
step
you
5.
want to go right now for that activity?
Copy. Thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
Welcome back. This month on Station Life, we're going to highlight the International Space Station as a platform for studying the Earth and take a behind-the-scenes look at what it's like to live and work aboard the International Space Station. You know, they say a picture's worth 1,000 words. The first pictures taken by humans from space forever changed the way we view ourselves and our world. If you've ever flown on an airplane in the window seat, you know the natural desire to stare out the window. Well, aboard the International Space Station, one of our favorite things to do during our off time is to stare at the beauty of our home planet.
Take a moment every day to look out the window and appreciate where you are.
Literally watch the Earth go by. We're going around the Earth once every 90 minutes. So you see a sunrise and a sunset every hour and a half.
It's just so vast and so vibrant in color, and so much contrast between the black that it kind of overwhelms you at first.
Don't just look out the window during the day. Go for the times between
day and night, and then night and day, and take some time to look out into the universe at nighttime, because that's when you can really see all the stars. And you can see that the stars are not only like in a planetarium where they're sort of in a 2D field, they're actually 3D, and some are farther than others.
But you could see the blues and the oranges and the reds and the whites and the yellows, and really see more color about the stars, which indicates more about where they are in their life cycle, what kind of things they're burning and doing. And you would think that you'd get tired of looking out the window, but you never do.
Like I said before, a picture's worth 1,000 words. But in the case of International Space Station imagery, a picture could also be worth 1,000 lives. An imaging system aboard the station called Environmental Research and Visualization System, ISERV, captured photographs of Earth from space for use in developing countries affected by natural disasters. This is yet another way the orbiting laboratory is serving humanity off the Earth for the Earth.
SERVIR is a joint NASA and USAID program where we're working with developing countries around the world and strengthening their ability to use satellites to address the many problems that they have, including floods, fires, harmful algal blooms, and other types of events that they have where they can use satellites to really make better decisions.
We're using space information to help decisions that affect people in the village where they live.
When there's a major disaster, governments around the world come together, and they provide all of the satellite data basically that the world has to offer. But there's smaller disasters that occur in the countries that we work in that may not make the front page of the New York Times, but in that country it's a really big deal. We asked ourselves, could we make a difference if we had a dedicated imager for acquiring imagery quickly after natural disasters, and to be able to provide that imagery back to the countries that need them, that have real decisions that need to be made with a very quick turnaround. As NASA, we looked in our own backyard and started thinking, could we use the International Space Station? The International Space Station was really a fantastic asset to take advantage of because it passes over 90% of the Earth's populated area every 24 hours. We developed an imaging system and we called it ISERV, which basically is a camera and a telescope system that sits inside the International Space Station and can collect imagery when it passes over natural disasters or other events that we need to collect imagery.
Initially, we were planning to take a few pictures per day.
So we contacted all the USAID missions around the world, and in total we had more than 2,000 requests coming, for people who need images from ISERV.
And we moved to like 1,000 images per day.
We provided ISERV imagery for many, many natural disasters, including floods and fires, for deforestation, for volcanic eruptions, for earthquakes. So it was really a fantastic example showing how imagery from the International Space Station could be used in these times of dire need.
And now we have a huge archives of images of areas around the world. So this is something that was not really there before.
ISERV is an example of, in essence, making the International Space Station even more international and connecting space to village to better understand and protect our home planet.
Imagine bread loaf-sized satellites zipping around the Earth each day, imaging the globe and providing updates on the environment. Thanks to the International Space Station, this constellation of satellite image gathering has been made a reality. With the mission of photographing the majority of the Earth every day, Planet Labs created small satellites, individually referred to as doves, to capture ground imagery for use in humanitarian, environmental, and commercial applications. With the 2005 NASA Authorization Act designating the U.S. segment of the station as a national laboratory, the space station drives growth of a robust commercial marketplace in space through endeavors like Planet Labs. The Earth imaging mission of Planet Labs' Dove satellites takes another leap toward creating benefits on Earth, resulting from innovation in space.
What happens if you wake up in the morning and you understand the state of the world as it is right now?
What could that data enable? How could people make smarter decisions? How could, for example, a farmer get better yield on his or her crops? How could somebody help disaster response? How can we use satellites to help humanity? That, in many ways, was the underlying thesis of doing Planet Labs, was to get data into the hands of people that could enable us to make smarter responses to that.
Planet Labs set out with the mission to photograph the entire Earth every day. And they thought, how are we going to do this? They said, let's build our own satellite.
Commercial imaging satellites, they're very large. They are very expensive. We took a different approach.
By making them really small, we can launch lots of them, and by launching lots of them, we can cover this, to get to this mission of imaging the whole Earth every day.
If we can do that, then we can literally change the way that we see the world.
And they called it the Dove. It's about the size of a loaf of bread.
Our doves are basically mainly a big camera with a telescope looking down to take pictures of the Earth. We initially developed the first Dove satellite in our garage. So we kept on iterating the Dove design, we made it better and better, and eventually we put our first one into space. We had no idea what the quality would be like.
I mean, we didn't know if it was going to work.
But we got an image down and it was so beautiful that we knew at that point we could make this technology work.
Wow, we can really do this, and we can achieve this mission, which is something that is really needed for us to understand global change.
So we had done a couple of demonstration satellites, but the next steps we wanted to do was to scale it up, to test the first fleets of satellites.
But what made that possible was actually access to space.
So here's the problem, that in order to take pictures of the entire Earth every day, you're going to need more than one or two satellites. You're going to need a whole lot of satellites, and you're going to need to be able to deploy them really fast. And really, there's only one obvious choice on how to deploy that, and that's the International Space Station.
There was no other platform in the world in order to get access to space of that fashion in that time period than the International Space Station.
NanoRacks is our key partner with NASA.
At NanoRacks, we understood Planet Labs' vision, and we knew that we could help. We worked together to figure out what was going to be the best way to get as many satellites as possible, and we basically developed a new platform. It goes out of the GIM airlock. It's picked up by a robotic arm, pointed out into space, and it fires these little satellites off of the space station.
They were able to secure 28 of our satellites to be launched from the International Space Station, and that was known as Flock 1, our first constellation.
This opened up the whole world to satellite developers, people that could put things into orbit fast.
We now deploy these on a regular basis from the International Space Station. And now today, we're able to operate the largest fleet of Earth imaging satellites in human history.
And none of that would have been possible without the International Space Station.
The International Space Station does enable young, small companies like ourselves to get going in space.
The ISS provides a lot of opportunities for commercial companies to test and find where the market in space is going to be.
And so what we're seeing today is a proliferation of new ideas and new concepts. It's almost like it's a renaissance of what's happening in space. Buckle up and strap down, because this is going to be a rocket for all of us in the global community to be part of.
I used to think when I was growing up in Florida, lots of thunderstorms in Florida, you know, that here's this storm over top of me and it's just this individual little thing that just is about a storm over Florida. And in fact, now after looking at the Earth from space, I see that that little storm in Florida is connected to Africa and Europe and all across the planet. And one of the most impressive things to see is how the Earth presents itself as alive when you're watching these storms at night just trickle across the whole surface of the planet like its own nervous system. And the emotions of the Earth, you know, seeing storms that are developing and the way you know from having that experience on Earth how it's probably impacting the people and the places down there. It's like, oh, is it upset and mad today versus the sunshine over some other part of the planet? And really, really, really gets you looking at it in a different way, an appreciative and respectful way. When you're crossing the deserts in Africa and the way the dunes form, I mean, they almost look like little, you know, birds have run across the sand. And then this contrast you'll get from kind of the pinks and oranges and whites to these dark grays and almost deep blues and of rocks and everything that are intersecting with it. And the Bahamas and the northern coast of Venezuela, which quite honestly is, I think, the most beautiful place on our planet. It is just incredible. Yeah.
Well, so far we've learned about using the ISS as a platform for ISERV, which captures imagery of the Earth to provide disaster assistance, and deploying small satellites called doves. We expect good things to come from both of these experiments and look forward to their robust potential. NASA has selected proposals for 2 new future instruments, Getty and EcoStress. These sensors on the ISS will give scientists new ways to observe how forests and ecosystems are affected by climate change. Our next piece is about a recently completed mission of an Earth-observing instrument on the ISS called HYCO. Its name stands for Hyperspectral Imager for the Coastal Ocean. Check it out.
Carroll Township's a very rural area in northern Ohio, right on Lake Erie. Lake Erie has always been very important to Carroll Township and its residents. We use it for drinking water, we treat it, and it's really our livelihood.
In Lake Erie, for what unknown reason, suddenly the toxin level spiked, and that got through the treatment system.
It was indicated to me that it is pretty dangerous.
Cyanotoxins can cause skin rashes,
Headaches,
nausea,
vomiting, stomach problems,
nervous system problems,
liver damage,
to death.
We sampled and we had about 2.5 times the limit from the World Health Organization. The second sample was approximately 3.5 times. Our plant wasn't set up to handle what was coming in from Lake Erie. One of my biggest worries was actually hurting someone or even worse. So we shut it off right away, shut everything off. We had a very close call that day. The last thing you want to do is produce an unsafe water and allow your people to drink it. What we need is a better way to track and predict these cyanobacteria entries from our source water so that we can make sure that this never happens again.
A lot of times we'll find out after the fact that there's a problem with cyanobacteria in the water because the bloom's already occurred. We either get results of sick animals or sick people. We need a paradigm shift. We need to go from being constantly reactive to these blooms to having a capability that allows us to become proactive. And the U.S. Environmental Protection Agency has been very encouraging of allowing for some high-risk, high-reward projects. And that allowed us to think outside the box, way outside the box. We've been fortunate enough to make use of a sensor on the International Space Station called HYCO, which stands for the Hyperspectral Imager for the Coastal Ocean.
HYCO consists of 2 instruments. One is a camera, and the second instrument is a spectrophotometer. which actually gives us the spectrum of light leaving that water.
The camera on a cell phone, for example, contains about 3 bands of data in a red channel, a green channel, and a blue channel.
HICO gathers light from the red, orange, yellow, green, blue, indigo, and violet parts of the spectrum. So using this technology, we're able to now detect those water quality parameters such as water clarity, what the phytoplankton concentration is in your water, how much light is being absorbed in your water, as well as what's the distribution of cyanobacteria in those waters, and does that concentration pose a health hazard?
So what this means is instead of waiting for someone to report that there's a problem with cyanobacteria bloom, we can monitor these water bodies from space
and get information that we can rapidly get out to the water quality managers through a smartphone application that we've developed.
So the app allows you to drop a pinpoint, and that pin can be placed in an area where a drinking water treatment plant may have an intake, and see what the current water quality conditions were. Each user gets that information near real time, so they can make judgment calls on whether they have to respond or take action.
Having the HICO on the International Space Station has been the ideal test bed for our research.
This is an amazing partnership. The Naval Research Laboratory had HICO on NASA's International Space Station. As HICO acquired a scene, it was transferred to the Naval Research Laboratory. And then the Environmental Protection Agency was able to do the analysis and the validation to send this information out through a prototype mobile application. Yes, this technology will reduce costs and provide near real-time information. But the big goal here is protecting humans. And if we can reduce exposures both to humans and even animals, then we've achieved our goal.
Our International Space Station is an unprecedented research platform in space, allowing researchers and scientists to conduct experiments that can't be done anywhere else. Utilizing the ISS as a ready-built platform for studying the Earth is well underway. So far, we've learned about ISERV, Planet Labs Dove satellites, and HICO. 2 more experiments, or payloads in NASA speak, are on schedule to get to the ISS later this year. There's SAGE 3 and Lightning Imaging Sensor. SAGE 3 will measure ozone and other gases in the upper atmosphere to help scientists assess the ozone layer and how it's recovering. And that Lightning Imaging Sensor will monitor global lightning for Earth science studies and support operational weather forecasting and warning. Looks like utilizing the ISS to further benefit all of humankind? It's right on track. Thanks for joining us on StationLIFE at our behind-the-scenes look at using the International Space Station as a platform for studying the Earth. And be sure to follow us on Facebook and Twitter for the latest research news. And don't forget to download our straight-up gangsta app on your mobile device. It's totally legit. Until next time, we're working off the Earth for the Earth.